As you can see, we're at gotomath.com working this stuff out. You want to come on over and check it out. We're doing the second derivative test, and 13-1, if I can get it to come up, you got to keep clicking. There's only two problems associated with that button. Anyway, it says use second derivative test and to find the relative extrema, and that means we're looking for minimums and maximums, right? And as you can see, here's the graph. Nice lovely graph here. And at that point right here, this is where the relative min is going to occur. And we're looking at just this little area right here, okay? So the relative minimum is occurring there. So we'll want to, we're going to want to write that down. X minus 1 raised to the 2/3 plus 2. Can we remember that? I'm going to try. K of x raised to the 2/3 plus, I believe that was 2, wasn't it? Yep. I tried to remember it. Alright, so the first thing we want to do, take the first derivative, bring the 2/3 over, subtract 1, you get negative 1/3. Derivative of the inside, bring it out, but the derivative is just 1. Derivative of 2 is 0, so we're good to go on that. Then we'll want to find the second derivative. We might as well just go ahead and do that now. So take the negative 1/3, bring it out front, and you end up with negative 2/9. Subtract 1 from negative 1/3. So we'll end up having negative 4/3, and the derivative of the inside, bring it out, it's just 1. Alright, so now what we're going to do is go ahead and rewrite this with positive exponents. So we have negative 2 up in the numerator, 9 down here in the denominator, x minus 1 raised to the 4/3. Alright? But the next order of business is we need to get that critical number, and that means we need to look at this guy here. Okay, so we're setting this equal to 0. We have 2, and then we have 3 down here, x minus 1 to the 1/3. So we look at what can make the numerator 0, nothing. What makes the denominator 0? It looks like x is equal to 1. Actually, I should label that maybe as our critical number. Okay, so remember about the critical number. This number here must be in the domain of k, and it is. You can plug 1 in, and we get 2 out. Alright, so that looks good. Now, what we're going to do now is, well, we just have 1, don't we? So all we have to do now is take this 1, this critical number, plug it into our second derivative, and determine if it is a negative or a positive that we get out. Well, if we plug 1 in down here, we get 0. And that's not good, is it? So, does the second derivative, can we actually find the relative mins or maxes using the second derivative? Well, if you plug it in, we need a positive or a negative number here, and we're not getting that. Doesn't look like it to me. So I don't guess we can use the second derivative to determine if it's a relative min or max. So these are things you got to watch out for, right? We got to watch out for that. So we'd actually have to right. So we can't do it that way. So what you got to be careful about is these things, and so we'd have to go back to the first derivative and draw the number line. Okay, now I had this in here just in case, we had issues like that, and then you'd have to do 0 and then 2, plug 0 into the first derivative, And what do we get? We get a negative number, right? We get negative, so we know it's decreasing. Then plug 2 in. We get, what do we get? We get a positive number, right? So we know it's increasing, okay? Decreasing, increasing. So this is not a trick here. I just wanted to show you that you got to be careful. Second derivative doesn't always work, right? So we got to go back and use first derivative. Like, wait, that's crazy. Let's go back to the graph. So you see the graph right here. We get concave down, and then we get concave down again. You see this right here? Okay. But it just doesn't work out, man. Shit's not working out there. Okay. When you use the second derivative. Let's hit the answer here. And we got a relative minimum at 1, 2. Alright. So there it is. And be careful, we're tricky here at GoToMath.com, and I'll see you later.